Subtraction of vectors. You know what? There is no such thing as subtraction of vector. What we need to do is we need to convert it in addition of vectors. Hello students, hope you have already done vector addition, all the three laws we have discussed. Now we will talk about, first of all, vector subtraction of vectors and then multiplication of vectors. Okay, so let us begin. Subtraction of vectors. You know what? There is no such thing as subtraction of vector. What we need to do is we need to convert it in addition of vectors. Subtraction of vectors will be the sum of vector and negative of another vector. Sum of one vector and negative of other vector. So when you have got this a minus b, if you have to subtract vector b from a, what you would do? You will add vector a with negative of vector b. So this is what we need to understand in subtraction of vectors. Okay, we have the concept of addition of vectors, and based on that we may easily find out the concepts. Okay, so let us work it out. What is this? This is vector A, right? This is vector A and this is vector B. This is vector A and this is vector B. Now negative of the vector would be here, in this direction, right? The angle between these two vectors, which we are supposed to find out, the sum will be 180 minus theta. 180 minus theta. This is what we need to do. Okay? This is what we need to do. And then simply you may get the vector sum as, sum of the what? Sum of vector A and negative of vector B. So this is a simple thing. You know how to do the addition, vector addition. Now one thing that you need to keep in mind is it is 180 minus theta. If you look at the basic concept which we have understood, so A minus B would be, magnitude of this would be what? You will say A square plus B square plus 2AB. What is the cos? What is the angle? Cos of 180 minus theta. Cos of 180 minus theta. So cos of 180 minus theta is what? It is A square plus B square minus 2AB cos theta. This is going to be your magnitude of subtraction of vectors, right? If you subtract two vectors, so in this manner you will get the result. Why so? Cos 180 minus theta is minus cos theta. So this is applied here. Okay, so this was the basic thing. This is what you got, and we will do questions based on this. So now let us move on to this multiplication of the vectors. Multiplication of the vectors. This also you can understand, you have already understood, and the direction of the resultant vector is this 10 phi, right? 10 alpha. This we have understood, this already we have done, right? So just note down the magnitude and direction of the resultant vector when you add the two vectors. Okay, when you add the two vectors. What vector? Vector A and minus of the other vector, right? So this was the stuff. Magnetic, the final result, magnitude of the subtraction of vectors would be this. We have already found, and the direction would be this. B sine, it is this, no? 10 alpha, just note down this thing. B sine 180 minus theta, and then what you will say? A plus B cos 180 minus theta. So ultimately what you are going to get? B sine theta upon 1 minus A minus B cos theta. Okay, so this is tan alpha made with this vector A. So this is the sum of subtraction of vector is sum of vector A and negative of vectors, right? Vector A minus B is what? A plus minus of B. I think you have understood this very simply, no? Now let us move on to the next topic, that is dot product. Multiplication of vectors. So two types of vectors, vector multiplication is there. One is scalar product or dot product. Another is vector product or cross product. So when you have resultant, when multiplying two vectors, you are getting another vector, then this is vector product. When you are multiplying two vectors and getting one scalar, then that is dot product or scalar product. Understood? So now, first of all, we will understand the scalar product or dot product, right? So just have a look. Scalar product or dot product of two vectors is defined as the product of magnitudes of vectors and the cosine of the angle between them. Okay, this is how to get it, right? When you are getting, mind it, when you are getting the scalar as a resultant of multiplication of two vectors, then that type of product, that type of multiplication of vectors is dot product or scalar product. Scalar is obtained as a resultant. That is why it is called scalar product, right? Come on. Now this. So be careful. In this, there is a significance also. There is significance. Why do we get this scalar product? Why do we get vector product? It has got significance. So right now, suppose you have a situation when you have to find out the component. Find out the component of one vector along another vector. Component of one vector along another vector. What you would do? You would do dot product. Okay, so just try to understand this very simple thing. So this is vector A and this is vector B. This is the angle theta. Theta is angle between them. Angle between A and B. Okay, so what is the definition? Definition is simply saying A dot B equals magnitude of vector A and magnitude of vector B and then cos theta. So there is no direction of this. Why so? We will simply get the magnitude, right? Okay. If you closely look, you will say that okay, this is B, vector B. This vector B and perpendicular, this component of this vector along vector A, component of this vector along vector A. So this could be written in this manner: A into B cos theta. If it is only written as A, that means we are taking the magnitude. That means this. We are taking only the magnitude, okay? So magnitude of A. Or some other way to do this is, if you have got this as vector A and this as vector B, then and this is theta, then what will happen? You will draw a perpendicular on this. The component of this will be B cos theta here. Okay, B cos theta. So this is also one of the ways to do. So A, so what did you do? You have taken the component of vector B along vector A. So this, the significance of, write down, significance of, physical significance. Physical significance of dot product. It is used to get the component of one vector along another vector, right? This is very simple thing that you need to keep in mind. How? Just have a look. If we now change it, if you have got B and you have got A here, so component of this A will be A cos theta here, A cos theta. So this will be from here to here, it is A cos theta. So, and this is B, vector B. So what will happen? A cos theta into B will give you A dot B. Understood? So this we need to keep in mind. Whatever is given to you, whatever vector, one vector will be given and another vector will be given. What you are supposed to find out? Component of one vector along another vector. So to get the component of one vector along another vector, you need to do dot product. Okay. Now let us move. Any example? Yes, two examples can be there. Examples. What examples? One is work, another is power. So work is the resultant of dot product of force and displacement. Power is the resultant of two vectors, force and velocity. Understood? Work is the resultant of scalar product of force and displacement vector. Power is the resultant of scalar product of force and velocity vector. So I'm writing here F is force, V is velocity, D is displacement. So if you ask yourself, work is a scalar quantity or a vector quantity? Yes, you know that work is a scalar quantity. What is power? Power is also a scalar quantity. So if you are getting a resultant as scalar, if you are multiplying two vectors and you are getting resultant as scalar, that is scalar product or dot product, right? And in this case also you are getting the same. These two vectors are multiplied and you are getting a scalar as a resultant. That is why it is a scalar product. Understood? Now let us talk about the properties, right? Talk about the properties of scalar product. See, I dot I equals J dot J equals K dot K equals 1. Can you tell me why? It is very simple. First of all, try to draw these. This is x-axis, this is y-axis, this is z-axis. So what you have, this is I cap, this is J cap, this is K cap. You are aware of this, right? As per the basic concept which we have used right now in dot product, it is I mod of this is what? 1, no? Magnitude, unit vector. So J cap or K cap. Mod of this equals 1. Okay. So if you are doing I dot I, so magnitude is 1 for both. Okay. This into what? Cos. What is the angle between I and I? 0 degree. Yes. So cos 0 degree. What is cos 0 degree? Cos 0 degree is 1. Cos 0 degree equals 1. Cos 90 degree equals cos 90 degree equals 0. Okay, so this is ultimately 1, right? Cos 0 is 1, these two, 1 into 1 into 1 is 1. Okay, so these are understood now. Okay, if you are multiplying I dot j, then what will happen? I dot j will be this. I and j are making, they are mutually perpendicular. So I and j, I dot j equals 1 into 1 into cos 90 degree. Cos 90 degree is 0. So finally it is 0. Similarly, you will have product of all perpendicular vectors. Now, what is the conclusion? Product of two perpendicular vectors is 0. Dot product of two perpendicular vectors is 0. Okay, this we need to keep in mind. Dot product of two perpendicular vectors is 0. Okay, this we have understood. Now, this is understood. There is no problem. Dot product of two vectors can be interpreted as the product of magnitude of one vector and the magnitude of the component of the other vector along the direction of first vector. So this we have already understood. Now, next property. A dot B equals B dot A. Since there is no sense of direction, because the resultant of dot product is a scalar, so what we can do is A dot B equals B dot A. There is no problem as such. So what we will say, it follows the commutative law. Okay, next. A dot A will obviously be equal to A into A magnitudes, because A is making 0 degree with this. So A dot A equals what? A square. All right. Now this A dot of B plus C. So what? Distributive property. It follows distributive properties. Okay. Now one very important stuff. Just have a look. If you have vector A as AX I cap, BX J cap, AX AY J cap, AZ K cap, vector B is written as this, BY J cap plus BZ K cap. Then A dot B, mind it, be very careful in this. A dot B, what you will do? If you will multiply this, what will happen? There would be 9 terms. Okay, out of 9 terms, 6 terms would have like this. Now I cross I dot J will be 0. I dot K will be 0, right? So similarly, J dot K is also 0. So out of 9 terms, only 3 terms will be possible, right? So simply you would say AX BX plus AY BY plus AZ BZ. So this we are going to get. Understood? Why I'm saying, I'm telling you, this is the result. So how do we get this? Let us have this picture. AX BX I dot I, okay, plus AX BY. So I dot J. So when you say I dot J, this is going to be 0, right? I dot J is 0. Why? 1 into cos 90 degree. We have understood this. Okay, so similarly AX BZ. So I dot K, again this is going to be 0. So similarly you would have 9 terms, and in all 9 terms, 6 terms out of 9 terms, 6 terms will have this sort of stuff. What? I dot J or I dot K. So this is going to be 0, right? So that is why final result is going, and this is going to be 1. So this is AX BX into 1, right? And there are multiple other terms. So where you will get this, J dot J is 1, K dot K is 1, But if you do j dot k, it is going to be 0. If you do j dot I, it is going to be 0. That's why out of 9 terms, only 3 terms will be left, and this is the result. Okay, so this is going to be your final result. This is very important. We will talk about one of the questions in this. Okay, so now this we have understood. Now let us move further. What is coming up? Let us see. This we have already understood. Fs cos theta, f dot s equals this. So it is work is a scalar product of force and displacement. We have understood this. Okay. Now, one more thing that you need to keep in mind is in this property, let's call this property 7. If you have got product of perpendicular vectors is 0. Dot product of perpendicular vectors is 0. Okay. Now let us take this question. Two vectors are perpendicular, right? This vector and this vector, right? What you are supposed to find out? This unknown value of this alpha. This is very basic question. You know, equally useful for boards and NEET, whatever. Very useful, very easy question. You want to know how to do this? Let us take. Let us take the dot product of this. For perpendicular, what you will say? For perpendicular vectors, A dot B equals 0. Okay, this is fine. Now, as per the given, vectors, let us find out the A dot B. So A dot B equals, just have a look. A dot B equals what? AX into BX. So 2 into 4. All right. This is plus. Okay, plus. And now what? Now you have 3 as AY and minus 4 as BY. So 3 into minus 4 plus AZ, 8 into this is alpha. So it will be 8 into alpha, right? 8 into alpha. So what is the final result? This is 8 plus, this is minus, no? 8 minus 4 into 3 is minus 12. 8 into minus 12 plus 8 alpha. So this is what we got as A dot B. So A dot B has to be 0. That means if you look at it, this is equation 1, this one equation 1, this one equation 2. From 1 and 2, what we get? We get 8 minus 12 plus 8 alpha. Obviously this is what? This is the resultant is this, no? This is minus 4. So 8 alpha minus 4. 8 alpha minus 4. So what we will put here? 8 alpha minus 4 equals 0. That means 8 alpha equals 4. That is alpha equals 4 by 8. That is answer is half. Right? Answer is half. Out of this, which one is half? Plus half or minus half? It is plus half. So answer is this. Understood? two perpendicular vectors. Dot product of two perpendicular vectors would be, dot product of two perpendicular vectors would be, yes, 0. Okay, let us do one thing. In this particular question only, now flip it. Let us flip it. You take this vector A as 2i 3j plus 8k. All right. Now vector B is 4. Oh, okay. Anyway, this was this was 4j minus 4i. Then there is something we are going to get differently. This was a mistake. This is where you need to be careful. Actually, this is plus j. We need to do it again. But anyway, we need to understand how to find out the angle between two vectors. How to find out the angle between two vectors, two given vectors, that we are going to do right now. Using, just take this. Using dot product. Dot product. Find out what? Direction of or find out angle between two vectors. Angle between two vectors. Find out angle between two vectors. Two vectors. Okay, so just have a look how we are going to do. So vector A is this 2i cap plus 3j cap plus 8k cap. This was there, right? Okay. Now this B equals 4. Okay, let's say minus 4i cap plus 4j cap plus what is it going to be? This is going to be, just have a look, 8, this is minus 8 plus 12, so 12 minus this, 4 and this 4 and 8. Okay, 8 alpha plus 4, so alpha is minus half. So alpha is minus half in this case. Okay, put it, alpha is minus half. So if this is minus half, you know what I am actually doing? I am already giving you, this is the condition of two perpendicular vectors. These are two perpendicular vectors we are, we are taking up. Okay, this is, you need to prove that angle theta is 90 degree. So let us find out that angle between these two vectors is 90 degree. How we are going to do this? Just stay focused. So cos theta, if you have got this basic idea, what is the purpose? To find out the direction of, find out the angle between two vectors, find out the angle between two vectors, given vectors A and B, okay? Given vectors A and B, angle between these two vectors using dot product. See how we go about it. So first thing is A dot B equals A, vector A into vector B, magnitude of vector A, vector B, and cos theta, right? So with the help of this, cos theta equals what? Cos theta equals A dot B divided by vector magnitude of vector A and magnitude of vector B. With the help of this, if you simply, and how to get this vector A, magnitude of vector A, it is going to be ax square plus ay square ay square plus az square. Magnitude of vector b would be this, bx square plus by square plus bz square, right? And a dot b we have already found, we know how to find it out. So a dot b divided by this, if you will do, you will get this cos theta equals 0. If cos theta equals 0, that means theta is 90 degree. Understood? Cos theta will be, if you will get this, you will get cos theta equals 0. If you will get cos theta equals 0, then what we can say? We can say that these two vectors are perpendicular. Okay? So this type of stuff would be given to you. Two. First one, the unknown quantities that we had to find out. Answer to this is going to be this actually. Because here, see, plus 4j cap minus 4i cap is given. So if you will do the calculations, the concepts which we have understood, if you will do that, result is going to be this. Okay? So in this unknown value for perpendicular vectors, this unknown value is asked. One type of question. Another type of questions, they will ask you to find out the angle between the two given vectors. How would you do that? You would get the dot product divided by cos theta equals cos theta. This is the angle theta. Theta is the angle between vector A and B. So it would be simply A dot B divided by vector A and vector B. Okay? So now in the next session, what we will do cross product, and maybe we will practice few questions based on this. For cross product, how it is different from the dot product, that one thing, and what are the physical significance, the sequence which we have already followed in this dot product, in the same fashion we will do that. Okay, and once we complete this vector stuff, we will move to, as we have talked about this motion in plane. In the first lecture, we talked about motion in plane has got these components, vectors, then we have got projectile, then we have got circular motion, right? Circular motion on the plane, motion in the plane, right? So we will do this. We will very soon finish off this chapter, and then we will move further. So what you are required to do is, whatever you have understood, practice properly. Okay, you will soon get the PDF notes and everything, whatever is there. Okay, so practice whatever we have done today.